Consider a grain silo consisting of a cylinder of radius 2r and height h, with a hemisphere directly on the top. This is shown in the following diagram. All lengths are measured in meters. The total surface area of the grain silo in square meters is given by S. The volume of the grain silo in cubic meters is given by V. In A part 1, we're asked to show that S is equal to 12 pi r squared plus 4 pi r h. So, the surface area is going to be pi times 2r squared. That's going to be for the bottom there. Then we have the curved surface of the cylinder, which will be 2 times pi times the radius, which in this case is 2r, times h, and then plus the hemisphere. The surface area of a sphere is 4 pi r squared, so for a hemisphere it's going to be 2 times pi times the radius, 2r squared. So that's going to give me 4 pi r squared plus 4 pi r h plus 8 pi r squared, which is 12 pi r squared plus 4 pi r h. A part 2 says, find an expression for h in terms of r if s is 120 pi square meters. So we have 120 pi is equal to 12 pi r squared plus 4 pi r h. Well, the pi's are going to cancel out of there immediately. We can also divide by 4, giving us 30 is 3r squared plus rh. So rh is going to be 30 minus 3r squared, and therefore h is equal to 30 minus 3r squared divided by r. Show that V is equal to 120 pi r, take away 20 upon 3 pi r cubed. Well, the volume is going to be the volume of the cylinder, which is pi times the radius squared times the height. And then, since we know the volume of a sphere is 4/3 pi r cubed, for a hemisphere that's going to be 2/3 times pi times its radius cubed. So that is going to give me 4 pi r squared times h, which I'm going to write as 30 minus 3r squared on h from the first part of the question, plus 16 pi r cubed upon 3. So I said upon h here, but of course it's upon r. The expression is just there from the first part of the question. And that means I can cancel that r with one of those r's there. And so I have 4 pi r, 30 minus 3r squared, plus 16 pi r cubed on 3, which is 120 pi r, take away 12 pi r cubed, plus 16 pi r cubed on 3. So, that is 120 pi r. Now this is 36 pi r cubed on 3, just to give it the same denominator as this one, plus 16 pi r cubed on 3, which gives me 120 pi r, take away 20 pi r cubed on 3, as required. So find an expression for dv dr. Well, dv dr is going to be 120 pi. And if we differentiate this, the 3 comes down and multiplies, but that will just cancel out with that 3. So we will take away 20 pi r squared. The grain silo has a maximum volume when r is equal to the square root of p, where p is a positive integer. Find the value of p. So we want dv dr to be equal to 0. And that means that we need 120 pi to be equal to 20 pi r squared. R's will cancel. R squared equals 6. R equals root 6, which means that P equals 6. Hence, find the value of the ratio H to R for which the grain silo has a maximum volume. Express the ratio in the form A to B, where A and B are positive integers. So H is going to be 30, take away 18 over root 6 with the values that we found, which means that H is equal to 12 over root 6. So H is going to be 6 times 2 over root 6, giving H is 2 root 6. Well, R is root 6, H is 2 root 6, so H to R is going to be 2 to 1.